Right now, the universe is still expanding faster than every known law of physics says it should, and NASA, Harvard, and the entire global scientific establishment have no way to stop it. Every new measurement makes the problem worse. Every new telescope confirms it. And what this widening crack in reality actually means is the part they're afraid to say out loud. This isn't a theory. This isn't a rounding error. This is something called the Hubble Tension, the single most unsettling number in all of modern cosmology. It is a measurement, a simple measurement of how fast the universe is expanding, and it doesn't match. The universe, according to one method, expands at roughly 67 kilometers per second for every megaparsec of space. According to another method, using real stars, real distances, real galaxies, it expands at 73. That gap is 9%. Across the entire observable universe. That's not noise. That's not a calibration issue. That is the fabric of reality contradicting itself, and it has been doing it for a decade, and the gap is still growing. Here's what nobody told you about how this started. For most of the 20th century, scientists measured the universe's expansion using the cosmic microwave background, the faint heat signature left over from the Big Bang itself. That method, refined for decades, gave a precise answer. 67. Clean, consistent, predictable. Then came a second method, a different team, different tools entirely. They built what's called a cosmic distance ladder, measuring nearby stars, then nearby galaxies, then distant ones, stacking each measurement like rungs until they could calculate expansion directly from the real physical universe we can see. And they got 73. They double-checked, calibrated everything. Reran the numbers, still 73. Two completely independent methods, two completely different answers. The discrepancy is now statistically significant at more than 5 sigma in physics. That means it is not a coincidence. It is not chance. It is real. But that's not even the part that worries them. The obvious answer should have been instrument error, a miscalibration somewhere, a bias buried in the data. Scientists spent years hunting for mistakes. New instruments were built specifically to check the math. The Hubble Space Telescope, the Dark Energy Survey, the Atacama Cosmology Telescope, every single one confirmed the same result. There is no error to find, no calibration fix to apply. And when the James Webb Space Telescope came online, the most powerful observatory ever launched into space, the expectation was that Webb would finally close the gap. Instead, Webb made the picture sharper. Webb found the same thing. 73 on one side, 67 on the other. The gap is not closing. And that's when the field stopped looking for a mistake and started asking a much darker question. Here is the strange part, and this is the part that actually breaks physics. If both measurements are correct and every attempt to find an error has failed, then one of two things must be true. Either our model of the Big Bang is wrong, or there is something in the early universe, something invisible, something we cannot detect, that changed the expansion rate before we were even here to measure it. Some physicists call it early dark energy, a phantom force that existed in the first fraction of a second after the Big Bang, drove expansion faster, then simply vanished. We have no proof it exists, no way to observe it directly, but without it, the numbers don't work. And here is what makes this truly unsettling. Our entire understanding of the universe, dark matter, dark energy, the Big Bang, the age of everything, is built on a single framework called lambda CDM. It is the foundation of modern cosmology. Every prediction we've made for 50 years rests on it. And the Hubble tension is not consistent with it, not even close. That means one of the most successful scientific models in human history may be fundamentally, irreparably wrong. And this is the payoff of what they wouldn't say at the beginning. They're not just confused. They're starting to wonder if the map they've been using to navigate the entire cosmos was never accurate at all. What that means for us goes beyond equations on a whiteboard. If the expansion rate is truly higher than our model predicts, the universe may be older and larger than we calculated. Or younger. Depending on which measurement you trust, the age of everything shifts by hundreds of millions of years. Stars our models say are older than the universe itself suddenly make sense. Dark energy, the invisible force driving everything apart, may be accelerating in ways our physics cannot account for. The universe may end faster than anyone predicted. Not some abstract number billions of years away, potentially far sooner. NASA's Webb telescope is still collecting data. Teams across the world are still refining measurements. But every new data point, every new analysis makes the same call. The gap is real. It is not shrinking, and no one is close to explaining it. So here is the question no one can answer. If the two most rigorous, most precisely tested methods of measuring our own universe give numbers that cannot both be right, then what else do we think we know that isn't true? The Hubble tension is still growing, right now, and nobody is coming to stop it. What do you think is waiting on the other side of it? Drop it in the comments because the scientists certainly don't know.